Good morning, students. In the last class, we are discussing about the question bank, that is part A for 1 month, right? So, today we start with the question 14, right? So, what is Ampere's circuital law, right? So, Ampere's circuital law is again, it is nothing but the Gauss law. So, it is similar to that of the Gauss law, right? So, in the Gauss law, what we did means we consider one imaginary surface. So, that surface we call as the Gaussian surface. So the total flux which are coming out from the surface is equals to 1 by epsilon naught times the net charges enclosed in that surface, right? So here in Ampere circuital law, so what happens means if we consider any one closed surface, right? So on this closed surface, the net magnetic field on the surface, right? So the magnetic field on the closed surface is equals to mu naught times the net current in the surface, right? So if we consider the current carrying the conductor I1, I2, I3 and I4, right? The magnetic field over the surface B, that is equals to, that is the line integral of the magnetic field over a surface is equals to mu naught times the net current enclosed in the surface. So mathematically we written that one, the line integral B over a closed surface, right? So for the closed surface, we taken dl, right? So where dl is the small surface, so at that surface we have, right? So for the total surface, so we are taken the integral, right? So magnetic field over the closed surface is equals to mu naught times the net current enclosed in the surface, right? So here we have the four currents. So all these four currents we call as the net current, right? That is I net. So where I net is equals to I1 plus I2 plus I3 plus I4, right? So this is similar to that of the Gauss law. So in Gauss law, what happens? If we have the charges, so we consider one surface. So this is also the imaginary surface. We call that surface as the Gaussian surface, right? So the net flux which is coming out from the Gaussian surface is equal to the one in that surface. So that means ಎಷ್ಟು charges is load ಇರುತ್ತೆ ಅನ್ನೋದಕ್ಕೆ equal ಆಗಿರುತ್ತೆ ಅನ್ನೋದನ್ನ Gaussian law ದಲ್ಲಿ ಇರುತ್ತೆ. So Ampere circuital law is similar, right? So here also it's saying the magnetic field over any closed surface. So now consider ಮಾಡ್ಕೊಳ್ತಿರೋ ಒಂದು surface ಅಲ್ಲಿ magnetic field ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ that is equals to the mu naught times the net current enclosed in the surface. So either it may be one conductor or two conductors. So ಎಷ್ಟು current ಆದ್ರೂ ಅದರಲ್ಲಿ include ಆಗಿರಬಹುದು, right? So Ampere's circuital law. So what it states means Ampere's circuital law, the integral, so line integral or integral value of it states that line integral value of magnetic field over a closed surface, right? So magnetic field in magnetic field over a closed surface is equals to mu naught times the net current flowing surface. So our surface ಅಲ್ಲಿ ಎಷ್ಟು current flow ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದಕ್ಕೆ mu naught times equal ಆಗಿರುತ್ತೆ, right? So mathematically we can write B dl, that is equals to mu naught into I, right? So this is the mathematical expression for the Ampere circuital law. So this is the explanation, right? So next 15th question, right? So what is magnetic declination, right? So magnetic declination is the angle between the magnetic meridian to the geometric meridian, so that we call as the magnetic declination, right? So important derivation definition: magnetic declination, right? So what is magnetic declination? It is the angle between magnetic meridian to geometric meridian, right? So ಇದು ಒಂದು angle ಇರುತ್ತೆ, so ಅದಕ್ಕೆ ನೇಮ್ ಕೊಟ್ಟಿರೋದು ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಡಿಕ್ಲರೇಷನ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, right? So next 16th question, right? So where on the earth surface is the magnetic dip is zero? So magnetic dip is nothing but the inclination, right? So at the equator magnetic dip is zero, at the poles the magnetic dip is maximum, right? So for 16, that is magnetic dip or inclination is zero at equator, right? So ನಮಗೆ equator ಅಲ್ಲಿ magnetic dip ಅಥವಾ inclination, so ಇದಕ್ಕೆ ಎರಡು ಮೀನಿಂಗ್ ಇದೆ, ಎರಡು ನೇಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. magnetic dip ಅಂತನಾದ್ರೂ ಕರಿತೀವಿ ಅಥವಾ inclination ಅಂತನಾದ್ರೂ ಕರಿತೀವಿ, right? So magnetic dip is zero at equator, so magnetic dip is maximum at poles, right? So that is at 90 degree ಅಲ್ಲಿ ನಮಗೆ maximum ಇರುತ್ತೆ, right? So move on to the next question. When will the magnetic force on a moving charge be maximum in the magnetic field, right? So that is, the charge is moving in a magnetic field, so we derive the relation for a charge moving in a magnetic field, that is again from the Lorenz force, right? So we have the relation F is equals to QVB sin theta, right? So this is the relation where Q is the charge, V is the velocity of the charge, and B is the magnetic field, right? So where sin theta, theta is the angle between the velocity and to that of the magnetic field, right? So in the question they ask when will be the magnetic force is maximum, right? So here when it is maximum means when sin theta value is 1, that is when theta is equals to 90 degree, so F is maximum and that value is equals to QVB, right? So ನಮಗೆ maximum ಯಾವಾಗಿರುತ್ತೆ ಅಂದ್ರೆ sin theta value 1 ಇರಬೇಕು, so sin theta value 1 ಯಾವಾಗಿರುತ್ತೆ ಅಂದ್ರೆ when theta is 90 degree, right? So if they ask for the minimum, that is for minimum theta is equals to 0 degree, that means the angle between velocity and to the magnetic field both are parallel. So velocity is also a vector quantity, magnetic field is also a vector quantity, right? So if these two are parallel, then the force will be minimum. So when these two are perpendicular, then the force is maximum, right? So minimum and theta is 0 degree, so F is equals to 0 because sin 0 is 0, so 0 into QVB is 0, right? So in bracket you can write B and D are parallel or anti-parallel, right? So 0 degree ಯಾವಾಗ ಸಿಗುತ್ತೆ ಅಂದ್ರೆ ನಮಗೆ velocity and magnetic field both are parallel or anti-parallel. So anti-parallel means theta is 180 degree, so 180 degree ಇದ್ರೂ ಕೂಡ ನಮಗೆ sin value ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. So maximum ಯಾವಾಗ ಇರುತ್ತೆ ಅಂದ್ರೆ when V and B are perpendicular, right? So V ಮತ್ತೆ P ಎರಡು perpendicular to each other ಇದ್ರೆ ನಮಗೆ theta value 90 degree ಆಗುತ್ತೆ, so F value ಏನಾಗುತ್ತೆ maximum ಆಗುತ್ತೆ. So ಇದು ನಮಗೆ ಕೇಳಿರೋ ಕ್ವಶನ್ ಅಲ್ಲಿ, ಬಟ್ ಅದ್ರ ಜೊತೆಗೆ ಮಿನಿಮಮ್ ಕೂಡ ತಿಳ್ಕೊಂಡಿರಿ. ಸೊ ಮಿನಿಮಮ್ ಯಾವಾಗ ಇರುತ್ತೆ ಅಂದ್ರೆ when V and P are parallel, right? So parallel or anti-parallel, right? So next, what is motional electromotive force? That is motional EMF, right? So what is motional EMF? So the EMF is induced at the ends of a conductor due to its motion in an uniform magnetic field. So magnetic field ಅಲ್ಲಿ ಯಾವುದಾದ್ರು ಒಂದು ಕಂಡಕ್ಟರ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಎಂಡ್ಸ್ ಆಫ್ ದ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ನಮಗೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅಂತ EMF ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಮೋಷನಲ್ EMF. That is motional electromotive force. So electromotive force ಅಂದ್ರೆ that is not a force, so that is the voltage, right? Motional EMF, right? So that is electromotive force, motional EMF, right? So motional EMF is induced at the ends of a conductor, right? So induced at the ends of a conductor due to its motion in uniform magnetic field. So magnetic field ಅಲ್ಲಿ ಕಂಡಕ್ಟರ್ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ at the ends of the conductor ಅಲ್ಲಿ ನಮಗೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅಂತ EMF ನ ನಾವೇನಂತ ಕರಿತೀವಿ? motional EMF, right? So the explanation is that consider the magnetic field. So cross mark indicates that the magnetic field lines are moving inside the board, right? That is moving into the plane of paper. So this is the uniform magnetic field. So definition ಅಲ್ಲಿ ಕೂಡ ಮೆನ್ಷನ್ ಆಗಿದೆ, motion in uniform magnetic field. So uniform magnetic field ಅಲ್ಲಿ ಕಂಡಕ್ಟರ್ ಮೂವ್ ಆದ್ರೆ ಮಾತ್ರ ನಮಗೆ motional EMF ಸಿಗುತ್ತೆ, right? So consider one conductor, right? So AB is a conductor which is placed in an uniform magnetic field. Now we need to move this conductor, right? So this conductor is moving with the velocity v. So velocity is a vector quantity, so it has a magnitude and direction. Again, the magnetic field is also the magnitude and direction, right? So EMF is induced at the ends of the conductor. So this conductor having the length L, right? So now conductor the length na L anta ತಗೊಂಡಿದ್ದೀವಿ, right? So consider a conductor having length L which is moving in a uniform magnetic field V, right? So moving with a velocity v. So explain, state and explain anta kelidre, consider a conductor of length L which is placed or which is moving in an uniform magnetic field with a velocity v. Then we have the relation. So regular class ಅಲ್ಲಿ ನಾವು ಅದನ್ನ derive ಕೂಡ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So here the induced EMF E, that is equals to, right? So that is equals to BLV sin theta. So this is the mathematical relation for the motional EMF, right? So where E is the induced EMF, B is the magnetic field, L is the length of the conductor, V is the velocity of the conductor, theta is the angle between the magnetic field and to that of the velocity vector, right? So theta is that if the conductor is inclined, then the velocity and the magnetic field also make some angle theta. So that is the value, that is the theta, sine of an angle between B and V, right? So here also we can discuss like this, when it is maximum and when it is minimum. So induced EMF is maximum when theta is 90 degree because we having sine theta, right? So when it is minimum when theta is 0 degree, right? So next 19th question, mention the significance of Lynch's law. So significance is the conservation of energy, right? So it proves the law of conservation of energy, that is neither be created nor be destroyed, that is converted from one form of energy to another form of energy, right? significance of Lynch's law, that is law of conservation of energy, right? So it verifies the law of conservation of energy, right? So next, what is self-induction, right? So it is a phenomenon of inducing EMF, right? So inducing EMF in a coil due to rate of change of current in that coil. So that we call as the self-induction, right? So what is self-induction means? The EMF is induced in a coil, that is due to rate of change of current in that coil. So we call that phenomenon is called as the self-induction, right? So question number is 20, right? The phenomenon of inducing EMF in a coil due to rate of change of current in the coil, right? So this is the definition of self induction. In the previous chapter also we discussed this topic, that is self induction and mutual induction. So if they ask for the definition of the mutual induction, the phenomenon of inducing EMF in a coil due to rate of change of current in the nearby coil. So self induction ಅಂದ್ರೆ same coil, so mutual induction ಅಂದ್ರೆ nearby coil. So nearby coil ಅಲ್ಲಿ ನಮಗೆ current variation ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ induce ಆಗೋದನ್ನ EMF. So that phenomenon ನಾವೇನಂತ ಕರಿತೀವಿ mutual induction. So if in case they ask for the mutual induction, so the definition is almost remains the same, but in the last we need to change it, right? So mutual induction ಅಂತ ಕೇಳಿದ್ರೆ ನಮಗೆ almost ಈ definition ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ಎಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಚೇಂಜ್ ಆಫ್ ಕರೆಂಟ್. ಸೊ ಇಲ್ಲಿಂದ ಏನಾಗುತ್ತೆ, ಚೇಂಜ್ ಆಫ್ ದ ಕರೆಂಟ್ ಇನ್ ಎ ನಿಯರ್ ಬೈ ಕಾಯಿಲ್. ಸೊ ಹತ್ರದಲ್ಲಿರೋ ಕಾಯಿಲ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಯ್ತು ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಕೂಡ ಒಪ್ಟೈನ್ ಆಗುತ್ತೆ. ಸೊ ಅಂತದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಷನ್, ರೈಟ್? ಸೊ ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್ ಮೀನ್ಸ್ ಸೇಮ್ ಕಾಯಿಲ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, EMF ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಅದನ್ನ ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ನಿಯರ್ ಬೈ ಕಾಯಿಲ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಚೇಂಜ್ ಆದ್ರೆ ಅನದರ್ ಕಾಯಿಲ್ ಅಲ್ಲಿ ನಮಗೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ 21st question, state Faraday law of electromagnetic induction, right? So Faraday law of electromagnetic induction is the magnitude of the induced EMF is equals to the, right? So here the EMF is induced, right? So the magnitude of the induced EMF in a circuit which is equals to time rate of change of flux or linked with the circuit, right? So current ಅಥವಾ flux, so ಎರಡರಲ್ಲಿ ನಾವು ಯಾವ್ದನ್ನ ಬೇಕಾದ್ರೂ ಮೆನ್ಷನ್ ಮಾಡ್ಕೋಬಹುದು, right? So Faraday law of electromagnetic induction that use what the mathematical relation for the self induction or mutual induction, right? So the EMF is induced in the coil which is equals to rate of change of, so rate of change means with respect to time, rate of change of magnetic flux which is linked with the circuit. So ಯಾವ ಸರ್ಕ್ಯೂಟ್ ಗೆ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ನ ಲಿಂಕ್ ಮಾಡಿರ್ತೀವೋ ಸೊ ಅಲ್ಲಿ ನಮಗೆ ಏನು ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ, EMF ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ದ Faraday, right? So Faraday's law of electromagnetic induction. So electromagnetic induction is EMI, right? The magnitude of induced EMF is equals to rate of change of magnetic flux linked with the circuit or coil, right? So this is the statement for the Faraday law of electromagnetic induction, and this is the mathematical relation, that is minus d phi b by dt, right? So minus that explains by the Lenz's law. Why we are taken the minus symbol, right? So next 22nd, state Lenz's law in electromagnetic induction, right? So again here we have getting the negative symbol. So this is explained by the Lenz's law. So that is the statement of the Lenz's law is, so state the Lenz's law in electromagnetic induction, right? So the polarity of the induced EMF. So we are getting the negative sign, right? So the polarity of the induced EMF is causes, so it tends to induce the current in the circuit which opposes the change in the magnetic field, right? So negative sign indicates what? The negative sign tends to induce the current. The polarity of the induced EMF is responsible for the induction of the current in the coil, that is current is induced in the coil, so that current opposes the change of magnetic field in that coil, right? So that is the statement of the Lenz's law, right? So if we consider any one coil, right? So from the Faraday law of electromagnetic induction, the magnitude of the induced EMF, so in this coil EMF is inducing, right? So that is due to the rate of change of magnetic flux. So when we are subjected to the change in magnetic flux, so magnetic flux ಜೊತೆಗೆ ಈ coil ನ place ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನಮಗೆ, that is varying magnetic flux linked with the coil, then current is induced, right? So that is EMF is induced, so EMF or current, so ಎರಡನ್ನು ಕೂಡ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ಕೋಬಹುದು, right? So here in Lenz's law what it explains means the polarity of the induced EMF is responsible for the induction of the current in the coil, so this current opposes the change in EMF. In EMF means the increasing value of EMF or decreasing value of the EMF, right? So one coil now varying magnetic field ಅಲ್ಲಿ place ಮಾಡಿದ್ರೆ EMF induce ಆಗ್ತಾ ಇದೆ, along with the EMF current ಕೂಡ induce ಆಗ್ತಾ ಇದೆ, so that current is responsible for the opposition of the change in EMF, right? So ಈ current ಏನ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ, so ಯಾವುದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ EMF. ಸೊ ಇಲ್ಲಿ ಏನ್ EMF ಬಂದಿದೆ ಅದು ಇನ್ಕ್ರೀಸ್ ಅಥವಾ ಡಿಕ್ರೀಸ್ ಆಗೋದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ, so that is given by the Lenz's, right? So Lenz's law, right? So it indicates the polarity of the induced EMF, right? The statement is the polarity of induced EMF is such that it tends to induce current in the coil which opposes the change in magnetic flux, right? So this is the statement of the magnetic flux that produced. Statement of the Lenz's law, right? So ಇದನ್ನ vice versa ದಲ್ಲೂ ಕೂಡ ನಾವು ಹೇಳ್ಬೋದು. When an coil is subjected to change in current, so change in current ಗೆ subject ಮಾಡಿದಾಗ EMF induce ಆಗುತ್ತೆ. So due to that EMF, current is induced in the coil. So ಆ EMF ಇಂದ ಏನಾಗುತ್ತೆ? It allows or it restricts the change in current. So induce ಆಗಿರೋ EMF ಏನ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ flow ಆಗ್ತಾ current na oppose ಮಾಡುತ್ತೆ. So inductance na ನಾವೇನಂತ ಕರಿತೀವಿ, in terms of resistance ಅಂತಾನು ನಾವು ಕರ್ಕೊಂತೀವಿ, right? So it is nothing but the resistance, right? So resistance means opposes the flow of charges in the conductor. So same like here, it opposes the variation of the current in the coil, right? So ಈ coil ಅಲ್ಲಿ current increase ಆಗೋದಕ್ಕೆ ಅಥವಾ decrease ಆಗೋದನ್ನ oppose ಮಾಡುತ್ತೆ. So ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, it is nothing but a resistance. So that we call as the inductance, right? So coil ಅಲ್ಲಿ ಅದನ್ನ inductance ಅಂತ ಕರಿತೀವಿ, conductor ಅಲ್ಲಿ ಅದನ್ನ ನಾವು resistance ಅಂತ ಕರಿತೀವಿ, right? So next, 23rd question, what is Lorenz force, right? So Lorenz force is the force which is experienced by a charge when it is moving in an when it is subjected to the both electric field and magnetic field, right? So ಯಾವುದಾದರೂ ಒಂದು ಚಾರ್ಜ್ electric field ಮತ್ತು magnetic field ಎರಡರಲ್ಲೂ ಕೂಡ ಅದು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತು ಅಂತ ಅಂದ್ರೆ ಅಂತದ್ದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, Lorenz force, right? So Lorenz force, it is the force experienced by a moving charge when subjected to both electric field and magnetic field, right? So ಯಾವುದಾದರೂ ಒಂದು ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಆ ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಯಾವ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇರಬೇಕು, ನಮಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎರಡೂ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಅಂತ ಚಾರ್ಜ್ ನಮಗೆ ಒಂದು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತಾ ಇದೆ. ಅಂತ ಫೋರ್ಸ್ ನಾವೇನಂತ ಕರಿತೀವಿ, Lorenz force ಅಂತ ಕರಿತೀವಿ. So in mathematically we write the Lorenz force F, that is equals to Q, which is the charge which is moving in both the electric field and magnetic field. So first we write the electric field E plus B cross B. So it is always B cross B because the cross product B cross B is not equals to B cross B, right? So cross product ಅಲ್ಲಿ ನಮಗೆ commutative law obey ಮಾಡೋದಿಲ್ಲ. So that's why always we need to take B cross B. If we take B cross B, then the sign will alter. So direction of the moving charge is changes. So charge move ಆಗ್ತಾ direction ಏನಾಗುತ್ತೆ, ನಮಗೆ change ಆಗುತ್ತೆ. So this we can write Q into E plus Q into V cross B, right? So Q into E is the force which is experienced by a charge when it is moving in an electric field, right? So here this is the force which is experienced when the charge is moving in the magnetic field, right? So hence both the field, the charge will experience as a force. So that force we call as the Lorenz force, right? So that is F L-O-R-E-N-T-Z. So suffix ಅಲ್ಲಿ ಅದನ್ನ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ, right? So next, state Curie's law ಇದೆ, that is 24th question. So ಅದು ನಮಗೆ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಇಲ್ಲ, right? So that is again induction, EMI ಅಲ್ಲೇ ಬರ್ತಾ ಇತ್ತು, right? So sorry, magnetism ಅಲ್ಲಿ ಬರ್ತಾ ಇತ್ತು. So ಆ ಟಾಪಿಕ್ ನ ಡಿಲೀಟ್ ಮಾಡಿರೋದ್ರಿಂದ so Curie's law ಅದನ್ನ ನೀವು ಸ್ಟ್ರೈಕ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, right? So next, 25th question, how does the power of lens related to the focal length of the lens, right? So power of the lens is related with focal length. So power is inversely proportional to the focal length, right? So focal length increase ಆಗ್ತಿದೆ ಅಂದ್ರೆ power decrease ಆಗುತ್ತೆ. So power focal length decrease ಆಗ್ತಿದೆ ಅಂದ್ರೆ power increase ಆಗ್ತಿದೆ. So this is the relation for the power and focal length, right? So power is inversely proportional to that of the focal length, right? Next, name the spectral series of the hydrogen which lies in the ultraviolet region of electromagnetic spectrum. So that is Lyman series. So number of series bರುತ್ತೆ electromagnetic spectrum ಅಲ್ಲಿ. So that is for the hydrogen atom. That is 26. Right. So spectral series of the hydrogen, right? So which lies in the ultraviolet region of the electromagnetic spectrum. So spectral series ಅಲ್ಲಿ UV rays, that is for the Lyman series. So ನಮಗೆ number of series ಇದೆ. Lyman series, next Palmer series. So next Pastel series. Bracket series and P1 series. So these are the electromagnetic spectrum that we observed in case of the hydrogen atom, right? So where these series will be observed, right? So ಯಾವ region ಅಲ್ಲಿ ನಮಗೆ ಈ series ನ observe ಮಾಡಬಹುದು ಅಂದ್ರೆ Lyman series. So that is in UV region, that is ultraviolet region. So Palmer series, that is in visible region of a spectrum. So Pastel series, that is near infrared region, that is IR region, right? So bracket series, that is mid IR region, mid infrared region, right? So P1 series is far infrared region. So in these regions we are observing the electromagnetic spectrum of an hydrogen atom, right? So in the question they ask, name the spectral series of the hydrogen which lies in the ultraviolet region. So ಯಾವ region ಅಲ್ಲಿ ನಮಗೆ ultraviolet ನ observe ಮಾಡಬಹುದು ಅಂದ್ರೆ that is Lyman series. So ಯಾವ series observe ಮಾಡಬಹುದು ultraviolet region ಅಲ್ಲಿ ಅಂದ್ರೆ Lyman series. So Lyman series ನ ಎಲ್ಲಿ observe ಮಾಡಬಹುದು ಅಂದ್ರೆ ultraviolet region. So vice versa ನಿಮಗೆ ಯಾವುದು ಬೇಕಾದರೂ ಕೇಳಬಹುದು, right? So next, define power of lens, right? So power of lens, it is defined as a tangent drawn, right? It is the tangent of the angle by which it converges or diverges the beam of light falling at a unit distance from the optic center, right? So if we consider this is the lens, right? So this is the optic center and this is delta. So delta we call as the power of lens. So how we define power of lens? So this is the incident ray, this one is the refracted ray. So it is the angle between, so tangent of the angle. So ಇದು angle ಅನ್ನು ನಾವೇನಂತ ತಗೊಂಡು, so these two are the alternate angles. So ಇಲ್ಲಿ delta ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೂಡ delta ಇರುತ್ತೆ, right? So ಇಲ್ಲಿ ನಮಗೆ focal length ಅಲ್ಲಿ converge ಆಗ್ತಾ ಇರುತ್ತೆ, right? So how we define the power of lens means it is the tangent of the angle, right? So which angle? It is the tangent of the angle by which it converges the ray, converges the beam or diverges the beam, which beam of light falling at a unit distance from the optic center. So optic center in the unit distance ಅಲ್ಲಿ converging ray ಬೀಳಬಹುದು ಅಥವಾ diverging ray ಬೀಳಬಹುದು. So ಅಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇರೋ ಆಂಗಲ್ ಅನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ? ಪವರ್ ಆಫ್ ಲೆನ್ಸ್, right? So 27th question, power of lens, right? Tangent of the angle. So ಇಲ್ಲಿ ಯಾವಾಗ ಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ, that is the tangent of the angle by which it converges or diverges a beam of light incident at a unit distance from the optic center, right? So e distance na unit distance, so unit distance is nothing but 1, so unit na ನಾವು ಏನಂತ ಕರಿತೀವಿ 1 ಅಂತ ಕರಿತೀವಿ. So again by using the tan theta, right? So tan delta from the trigonometry, so tan delta is the opposite side by adjacent side, so opposite side is h, so adjacent side is f, that is the focal length. So in the definition, when we call this angle is power, so when the ray of light is incident at a unit distance from the optic center, so unit distance is nothing but its distance is 1 unit, right? So that means h is equals to 1, then tan delta we call as power, right? So power is equals to 1 divided by f, right? So that is when h is equals to 1. So that is again from the definition, tangent of the angle by which it converges or diverges a beam of light incident at a unit distance. So unit distance from the optic center, right? So h becomes 1. When h becomes 1, tan delta becomes power, right? So unit of the power is diopter. Adunu kelbodu. So diopter is the unit of power or per meter. So meter to the power minus 1. Next, 28. What is diffraction of light? So it is a phenomenon of bending of the light around the obstacle or sharp edges, and hence the enforcement of the shadow region, right? So ಯಾವುದಾದ್ರೂ ಒಂದು ಶಾರ್ಪ್ ಎಡ್ಜಸ್ ಅಲ್ಲಿ ಬೆಂಡ್ ಆಗ್ತಾ ಇದೆ ಲೈಟ್, ಸೊ ಹೆನ್ಸ್ ದೇರ್ ಇಸ್ ಅನ್ ಶಾಡೋ, ರೈಟ್? ಸೊ ಅಲ್ಲಿ ಬೆಂಡ್ ಆಗ್ತಿರೋ ರೀಸನ್ ಇಂದ ನಮ್ಗೆ ಅಲ್ಲಿ ಶಾಡೋ ಬರ್ತಾ ಇದೆ, ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಡಿಫ್ರಾಕ್ಷನ್. ಸೊ ವಾಟ್ ಈಸ್ ಡಿಫ್ರಾಕ್ಷನ್? ಸೊ ಇಟ್ ಈಸ್ ದ ಬೆಂಡಿಂಗ್ ಆಫ್ ದ ಲೈಟ್ ಅರೌಂಡ್ ದ ಎಡ್ಜಸ್ or obstacles, and hence the enforcement of the shadow region, right? By the light, that is shadow region by the light, right? So that we call diffraction. Bending of light around the edges or corners of an obstacle, and hence shadow region by the light. This is the definition of the diffraction, right? So next, 29th question. Name the spectral series of the hydrogen atom in the visible region of the electromagnetic spectrum. So ಯಾವ series ಕಾಣ್ತಾ ಇದೆ ನಮಗೆ visible region ಅಲ್ಲಿ ಅಂದ್ರೆ, that is Palmer series. So ultraviolet region ಅಲ್ಲಿ ನಮಗೆ Lyman series ಕಾಣ್ತಿದೆ, visible region ಅಲ್ಲಿ ನಮಗೆ Palmer series ಕಾಣ್ತಿದೆ. So maximum ಇವೆರಡನ್ನೇ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ, because in question if they ask for infrared region, so ಈ ಮೂರಲ್ಲಿ ಯಾವ್ದು ಬರೋದು ಕೂಡ ನಮಗೆ ಅದು ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ, right? So next, 30th question. Write the SI unit of radioactivity, right? So SI unit of the radioactivity is becquerel. So becquerel ಅಂತ ಬರೀಬೇಕಾದ್ರೆ ನಮಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಲೆಟರ್ ಸ್ಮಾಲ್ ಲೆಟರ್ ಅಲ್ಲೇ ಇರಬೇಕು. So if in case if we return into the capital letter means again it will go strong. So ನಿಮಗೆ ಇದು ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದ್ರೆ BQ ಅಂತ ಏನಾದರೂ ಮೆನ್ಷನ್ ಮಾಡಿ. So SI unit is becquerel. So capital B, small q. So in terms of words, then it starts with small b, right? So next 31st, define half-life of a radioactive sample. So ನಿಮಗೆ half-life, mean life, so radioactivity ಕೆಲ ಇದಿಷ್ಟು ಕೂಡ ಸಿಲೆಬಸ್ ಇಂದ ರಿಮೂವ್ ಮಾಡಿದ್ದಾರೆ. So 31 ಕೂಡ ನೀವು ಸ್ಟ್ರೈಕ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, right? So these are the few more important questions, right? So in the next class we start with part B, right? Thank you.